So what is DevOps? And for me, DevOps, when I think about DevOps, the biggest thing that I think about is, at the end of the day, is the fact that its goal is to drive value to your end users, to your business, to your customers, right? A lot of times these we talk about DevOps and the business is like, well, what's in it for me? And showing the business, great, I can automate my build. Okay, so what? Why does the business care about automating the build? The other big key that I think to DevOps is the fact that it's this union of not only products, right? Microsoft, we have products, right? There's a lot of open source products out there, right? But it's also this union of people and process. And I think that's where a firm like CACI can come in and really help change, help move the needle, right? We can give you tooling. We can make sure that tooling works well with open source tools and whatnot. But we really need your help going to your customers and frankly our customers as well, and helping them with that process, helping them with the people changes that it takes to make DevOps a real game changer in their organizations. And that's where I think things like your community of practice really shine, insofar as you guys get this nice ability to cross-pollinate across your organization on how to best help your customers on that journey, right? Just throwing a new tool in front of somebody isn't going to really help them if they don't have the people and processes to take that tool and really make it shine. So so why is this important, right? So a lot of this has to do with things like being able to deliver more frequently with increased revenue, right? So I know a lot of you guys work in the government space, so revenue is really not a thing, but increased services to the constituency, which I would argue is revenue for me as the taxpayer, since I'm paying for those services as a taxpayer, right? Our businesses are asking us for websites and applications that are up 24/7. No longer is it acceptable in many cases to say, well, we're bringing the website down for 4 hours on Saturday night to do this upgrade. Right? No longer is it acceptable to say, no problem, we'll get that feature in, it'll be 6 months. Right? Organizations now are expecting, customers and constituents are expecting that changes happen at really fast, right? That we can go from idea or bug to fix really fast without a massive 6 months release cycle and things of that nature. And hopefully today, especially in the demo, we'll show that the tooling will help you on that journey, right? And we really look at, there's 3 different ways that our tooling can really help you. First, it's super flexible, right? Azure DevOps, Azure's in the name, right? So when I think about Azure in the name, I think about the fact that, well, Azure DevOps has 2 modes of running. I can either run Azure DevOps as a PaaS service, which is what I'm going to show today, where I have Azure DevOps running out on the Azure Commercial Cloud. The beautiful thing about that is, well, now I don't have to worry about upgrades and patching and storage and blah, 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 blah. My DevOps tooling just works. It's just there for me. I can also run Azure DevOps on virtual infrastructure or physical infrastructure inside of my environment. So if I have a need for a isolated environment, an environment that's on premise or whatever, we have this tool called Azure DevOps Server. It's the replacement for Team Foundation Server, which can run on a virtualized environment or physical environment inside of your data center, your customer's data center, inside something like Azure Government, or frankly, even on another cloud. It also has a lot of tooling built in to make your work easier. And that's where we go into the powerful pillar of Azure DevOps, right? The tooling obviously integrates well with our stuff, but also integrates well with tooling from other vendors to give you the ability to do your job faster. And that other vendor piece is that open part, right? This isn't the Microsoft of last year or last decade, right? This is the new Microsoft. We're members of the Linux Foundation. We're one of the largest contributors on GitHub. We spent a couple of $1 billion to help the open source community by funding GitHub and purchasing them. So there's a lot of things that we're doing. We see things like open sourcing .NET Framework and things like that, where we're trying to be valued members of the community. We look at it from a point of view of look at what we're doing now and look at the work that we're doing. I think it's really valuable for us, even if you're not building open source software. So, was somebody say something?
I was going to say, Sean, just to kind of underscore that point, because I know in some of our previous discussions, I think there is a misconception of some folks that you kind of have to be a Microsoft shop and you have to be, running or building .NET applications and running Team Foundation server, etc. And that's not necessarily true, as you mentioned, given the adoption on the open source side. So I just wanted to kind of foot stomp that. I think it's a good point.
Thank you. Yeah. Well, and Azure DevOps is not just for deploying to Azure. I can use Azure DevOps to deploy on-premise applications, phone applications. We have build servers in Azure that are running Mac OS and Linux. So you can build iOS applications and you can build Linux applications. So there's all kinds of things that are available for you when we start digging into the platform. So when I look at DevOps, I look at these three big pieces of DevOps, and we're going to see a lot of this in the demo today. The first one is continuous integration, right? This is the concept, and you guys know this, the concept of being able to go from source code to compiled application. Now, once I have that compiled application, I want to be able to continuously deliver that application. And when I deliver that application, I want to be able to take those same compiled bits and bring them across all of the environments that I need to drop them in, dev, test, production, what have you. And I want to have that whole process not only automated, but also audited so that I know which versions of code are in which environments with which configuration. And I know who signed off on that code to get deployed to that environment so that I have full audit trail for all of the compliance and whatnot work that we have to do. Now, just having your code out there in production isn't enough anymore. We also have to be able to look at that code, monitor that code, and learn from that code when something goes wrong. Right? I want to be notified. I want to have a dashboard to see what's going on in my application. I want to be notified when there's a problem, not from my users, not from my manager, not from the CEO of the company, and for heck no, not from the front page of the New York Times. I want to be notified from my application. I want my application to tell me, hey, there's a problem over here. You need to go take a look at it. And oh, by the way, it's not some screenshot that contains no information. I want to know all of what's going on in my application, stack traces, URLs, what's the IP address of the customer that hit me, right? Where are they coming from on the planet? And I want to be able to gather all of that information, and I don't want to have to do a lot of work to go do it. So Azure DevOps has 5 key pieces to it. Notably not here is the monitoring piece. That is because the monitoring piece is a piece of Azure proper. So keep that kind of tucked away in the back of your mind. So the 5 key pieces of Azure DevOps are Azure Boards. Azure Boards allow me to do all my work item tracking information. Azure Boards allow me to do all my work item tracking information. So being able to gather requirements and bugs, be able to prioritize those, being able to figure out who's doing what and when, using not only things like Agile and CMMI, but being able to customize that process. So it gives me this ability to manage the work that goes into making my code. Once I make that code, I need a place to put it. That's where Azure Repos comes in. Azure Repos supports both Git version control and Team Foundation version control. So if you want to do centralized or decentralized version control, Azure Repos allows you to store all that code. Once I have my code, now I need to build and deploy that code. That's where Azure Pipelines comes in. Azure Pipelines allows me to build out, run tests, and then deploy my code across all of my environments. Azure Test Plans helps me with managing all of those tests. And Azure Artifacts is my repository for components of my application. So for a .NET application, that might be a NuGet package, it might be a Maven package, it might be a NPM package, but all those packages that I build in. I know a lot of secure environments, they don't want you to pull random packages off of the internet. You have to pull them out of a secure repository, and Azure Artifacts can be that secure repository, or Azure Artifacts is that secure repository. So I've shown you, we have these 5 major components. And the slides have some more details. I'm not going to drain them today because I really want to spend time going through a demo. I mean, I talked about a lot of this stuff. So I've talked about our love of open source, and you can see all the things that we've open sourced. You guys aren't working on at work, probably you're not working on open source projects, but outside of work, if you are contributing to an open source project, we give you free unlimited build minutes for open source projects online, which is kind of cool. It's also integrated with GitHub, since open source projects tend to put their source control out on GitHub. You can use Azure Pipelines for free from GitHub for open source projects. And I'm going to skip through a lot of this stuff because I'd rather just show it to you. Okay, so let's do a demo. And I am just about on time. I like being on time. So I built a little application for you guys. Now this application is highly beautiful. It is a little, I deployed it to Azure because that's the easiest thing for me. It is a little .NET Core application that runs on Linux, packaged in a container. The Linux instances are running on Azure App Services, and you can see I have 3 instances running. One I'm calling dev, one I'm calling test, and another one I'm calling production. So let's go look at the production one for giggles. If I drill into that guy, and I'm not going to belabor Azure App Services because that's not really the purpose of today, but you can see I have a beautifully running, highly complicated sample application. Okay, so that's a little tongue-in-cheek. It's not very highly complicated. It is pretty much the default sample.NET Core application. So I can pull it up. It looks good. I have my home page, I have my contact page, and I have an about page. Uh-oh, my about page is broken. That's not good. Let's see if we can figure out what's going on with this about page. So our users probably aren't going to tell us about this. They're just going to click away and forget that some problem happened, and whatnot. So let's go look in Application Insights, our monitoring tool. Let's go look in that monitoring tool and see if we can't figure out what happened to our site. So our monitoring tool has this beautiful dashboard capability inside of Azure that allows me to get a single pane of glass kind of look at what's going on. Now this dashboard is the default way it comes out of the box. I can go ahead and edit this dashboard. I can move the widgets around. I don't like that widget over there. I want to pull that widget over there. I could change these things. I can add new widgets. So I can change that dashboard up to what makes sense for me. So if we look at our dashboard, we can see that it kind of gives me a good look of what's going on my application, from who's using it, reliability, responsiveness. But we can see I have a spike in reliability issues right around now. So let's drill in on that and see what's going on. So we can see that my error, if we drill into just about now, we can see, oops, I drilled in too far. Let's drill out some. We can see I have errors. Somebody keeps on requesting this robots.txt file. We're not going to look at that too much, but here we can see our home about page has thrown some exceptions, right? So I can see them in the dashboard. I can get an idea of what's going on. I can see what are my most popular problems. I can see what's going my top response codes, right? And I can go ahead and pull in actual details about those errors. So if I pull up that error, I can see end-to-end trace. Well, my application's super simple, so you don't see any dependencies in here. But if my application was calling, let's say, a SQL server or an HTTP endpoint as a dependency, I would see all of those dependencies in here, just like a request trace that you would see like in a browser window of client-side execution. Here I can see it from a server-side point of view. I can also look at much more detail about what's going on. So this is the actual URL that was called. It came from Austin, Texas. I don't know who lives in Austin, Texas besides me, but hey, it tells me what web server served up my request. So I get all kinds of great telemetry. I even have access to query the logs that are generating all of those charts. I can even write queries. We call this query language custo. So I can really dig in and write my own queries to pull out the information that's important to me. But this is our problem, right? Somebody needs to go fix this problem. So what would you typically do? Maybe you'd take a screenshot of this, send an email, call up somebody and say, hey, go file a bug request for me. Since these tools are integrated, what I can do from right here is hit create work item, and that will go ahead and create a work item in my configured source control system. So right now I have it configured to use Azure DevOps and our Azure Boards service, but it could also be configured with to file that bug in like GitHub. So if I go ahead and click OK there, it will go ahead and create a work item for me. So now I've had my operations team file a bug. Let's go look at that bug. So I am the guy who needs to triage new work that comes in, and you can see that bug that we just created has appeared in on our board, on our Kanban board, in the new column. I'm going to zoom in a smidge. Appeared right in our new column, right? So the work is ready for us. I can drill in on that work item card and pull up all the details for what's going on, right? So all the stuff that we just saw in Application Insights, I didn't have to rekey that in. I didn't have to retype anything. All that information is right there, along with the tokens that I need, the request information and whatnot. I need to go look up that request if I need to go find out more details. Okay, so let's start working on this problem. So we're going to change it from state. We're going to change it active. And we're going to start working on it. And you can see that moved it over to the next column. And I'm assigned to work on it. So I'm going to go ahead and work on this problem. We know this problem has something to do with our home about page. So let's go look at our code. Now, I'm going to edit the code today in the browser. You can obviously edit this code with whatever tool you use to edit your code that you love. Visual Studio Code, Visual Studio, JetBrains, you name it. It all works. It doesn't matter. I'm just editing it in a browser because it's super easy for me to do it real quick for you. So I'm going to go ahead and fix the problem. If you're not a .NET developer, when you write throw new not implemented exception in your code, it throws a new not implemented exception. So if we comment that guy out, it will no longer throw the not implemented exception and fix our problem. Wouldn't it be nice if all bugs were that easily fixed? So I'm going to commit this change. And you can see that it's prompting me for a couple of things. Which branch do I want to commit it in? And what work items do I want to link it to? So now I not only have traceability from the problem that happened, right, the application insights error message, to the bug, the request to go fix that problem, but I now can link it to the issue, to link the code change to the fix, right, to the work that was asked for. Now, this is a bug, but it could be done like that for a new feature or what have you. Just so you know, while I'm doing this in the browser, if I wanted to link this right from the Git command line or from any Git tool, all I would have to do is put number #72 in my comment like that, and that would automatically link that work item to that change request. So I'm going to go ahead and commit this. And it's going to give me an error. It's saying, hey, you're not allowed to commit changes directly into the master branch. Obviously, that's not a good feature, not a good way to develop code, right? I need to commit my changes into my feature branch. So I'm going to create a feature branch, and we're going to call it Sean fix the bug. So that's going to be my beautiful feature branch. And I'm going to commit that change into that feature branch. So let's go look at that branch here real quick. And we can see there's my Sean fix the bug feature branch. I can create now a pull request to ask Azure DevOps to, hey, let's merge Sean fix the bug back into master. Well, what did I do? It gave me some suggestions there. It has a linked work item. I can also suggest reviewers to review my code, and I get a little look at, well, hey, what changed? Again, my simple little commenting out one line of code. I'm going to go ahead and create that pull request. Now that pull request has kicked off. Now, part of a pull request process is not only the chance for people to go in and look at your code. In this case, I have a policy that states that one person has to review my code before that pull request can move along. So I'm going to go in and I have it set to so I can self-approve it. But obviously you probably wouldn't want you wouldn't want to approve your own request. We can see that I have another policy on here that says there's a build. So I have a build that's running that has to succeed before this pull request gets approved or completed. So I'm gonna so I'm gonna go look at that build request. And you see that build request is running right now. Let's actually drill into some details of that build request of what that build is doing. So that build does a number of things. Namely, it restores my NuGet packages. It does a build of my .NET project. It runs all of the unit tests that I have inside of my .NET project to make sure that all of my unit tests are passing. And now it's also running a third-party tool, in this case, White Source Bolt. What White Source Bolt is a static code analysis tool to see if you're using any deprecated or out of date packages in your build. So I've integrated this with an open source tool there. Now all of this has to complete before my pull request can move on to the next step. So let's actually, while we're waiting for that to happen, let's go look at White Source Bolt here for a second, because I think it's super cool. While it's not even a feature of Azure, I still think it's super cool. So and again, I'm just using the free version here. But what it's done is done a scan of my package and said, of my project and said, hey, you have this jQuery thing and it's out of date. You need to update it to at least version 3, because version 3 they fixed a cross-site scripting attack vulnerability. So that's very cool as we start pulling in all kinds of projects, all kinds of open source packages and whatnot into our projects. So let's go look at that build and see where he is. So our pull request build is still running. It's running that White Source Bolt on now. You can see all my tests passed. I love when my tests pass. And now he is all finished. Okay, so my build is completed. And if we go look at our pull request, we can see that my pull request has also been completed, right? Everything finished. My pull request has been completed. So I'm going to go in and click the complete button, and that's going to merge my code back into that master branch. So now my master branch has my big fix to fix this error. Now that my master branch has that, I have another pipeline, another build pipeline that will kick off. In this case, I have it called the CI build. It's triggered on any check-ins to the master branch. So it has automatically started kicking off and started building out my application to get it ready for deployment. So let's go look at that build pipeline. You see that build pipeline looks very similar to the build pipeline we had a moment ago, right? I do a restore, a build, I rerun my tests. In this case, I'm doing another step, .NET publish. That's going to copy my .NET project to a folder on my build machine, where it's going to all the pieces are going to be sitting. And then finally, I call out through this Docker command, this Docker step, to go ahead and build and publish that folder into a Docker container. And in my case, I'm deploying out to Azure Container Registry. So my compiled application then becomes a container out on Azure Container Registry. So if we flip back over to Azure, I can show you, if I go to my resource group, I have my container registry. Now, I've used Azure Container Registry. I really like it because it's close to where my application is, so it makes my deployments faster. But I could have deployed this to any container registry, Docker Hub, what have you. So in my container registry, I have a repository. Inside of my repository, I have all the versions of my application. So build 200, build 203. So all of those versions of that application are sitting out there in my container registry, ready to be deployed, or frankly, ready to be rolled back if I have a problem with one. So let's go check in the status of that build. How are you doing, Mr. Build? You are still running. So it is running my tests right now. So this is a good spot for me to take a breath and me to check in with you guys to see if you guys have any questions. Looks like Russell is having some problems with the demo, with seeing some stuff, but it looks like hopefully that's fixed.
Any questions from the group?
It's a quiet bunch, quiet bunch. Because I know my words aren't that exhaustive to be able to answer every
I've got
question.
one question.
Sure.
My name is Darius. How easy or straightforward is the upgrade path now? In our case, we're still at TFS 2010, so no applause there. But how straightforward is the upgrade path going from something like that all the way to DevOps server?
So we have some automated tools to help you on that journey, upgrading from TFS to Azure DevOps. And I have a link to, I could swear I put a link to that documentation at the end of the deck. Frankly, I've been using the Cloud PaaS version for so long that I'm lucky insofar as I never have to think about upgrades and whatnot ever again, because it's just handled for me. But yeah, so there's some documentation available, and I could swear I put a link to that in the deck.
Okay, I'll then look for that, because right now we're using, as I said, TFS 2010 with SharePoint services, and I'd like to move further than that. My initial thought was going to 2015, but if there's a clear upgrade path to DevOps server, my thought was to basically set up the DevOps server in our AWS cloud, and then is there an integration with SharePoint on that and project server like there used to be, or is some of that architecture changed?
So a lot of that stuff has changed to kind of remove some of those dependencies. While I'd love for you to be able to, there's nothing preventing you from installing DevOps server on AWS on a VM, I'd love for you to put it on Azure on a VM. But hey, that's just me being selfish.
We're somewhat restricted about where we can place our source code and stuff. So right now, that's the more agreed upon location. But that's not to say that I'm assuming once you get onto DevOps server, the jump to actual full DevOps on Azure will probably be not as challenging.
Yeah.
Hey, Darius, I put the link that Sean was referring to in the chat window.
Oh, I appreciate that, mate. And again, if somebody else has any questions, I'll defer to anybody else. This was just something that came up that I'm interested in.
Yeah.
No, I mean, that's great. Questions are good. Go ahead, Sean.
Yeah, beautiful. Yeah. So I mean, yeah, and we've just announced even top secret level Azure clouds for U.S. government workloads. So while there might be some paperwork and some people problems to work through that I'm sure Praneet would love to help you guys with, there's no, in my mind, there's no technical reason why it couldn't happen. or compliance reason why we couldn't host it on Azure. And like I said, that doesn't mean that you have to. There's nothing preventing you. I mean, you can run it in a VM anywhere. But then, like you mentioned, right now you own upgrading it every 6 months or so. You also don't get all the latest features and whatnot, because those features, obviously, we can't ship service packs to an on-prem product every 2 weeks, because you guys would shoot us in the head with having to upgrade it every 2 weeks.
Sure.
And so Simpath has put in the chat, can we integrate with Jira or Confluence? So you can integrate with many third-party tools or open source tooling. I showed you a path, and I'm demoing a path that uses our stuff from end to end. I think that provides you the most integration, the most ease of use. But if you have an investment in something else, whether it's Jira, Confluence, Octopus Deploy, Jenkins, whatever, if you have an investment over there, I am by no means telling you that you have to rewrite all that stuff, right? I would start by looking at the tools and using the tools that make sense for you and can add the most value for you and your customer. So we can see that my build pipeline, my CI pipeline has finished. Everything's green. I like green. So that once that build is complete, right? Like I said, it drops that container out in the container registry. You can see I have a new one called 205. And that will automatically kick off a release pipeline. Now I have this set to be completely automated out through into my dev environment because that's the way I chose to do it. But you can see that it has now dropped the release into my dev environment. You can see it's green, but you can see our test environment is blue here. And if I hover over it, it says it's waiting for me. So if I go and click on that guy, we can pull up its details, and it's saying, hey, before I can go out to the test environment, I need approval from some human. That's the way I have mine configured. I don't want code to just drop into test. I want the test manager or whoever to be able to approve it. And I don't know if you saw the email toast come through, but I also get an email that says, hey, Sean, this thing's waiting for you to approve. So I'm going to go ahead and approve. I can even defer it and say, go ahead and approve it at Friday night at 5 o'clock or what have you, if I want to deploy, if I want to drop that at the end of the day, right? My testers are busy working on it now. Let's wait till they go home before it goes out. So I'm going to go ahead and approve that guy. And while that guy is running, I'm going to go flip back over to the release so you can kind of see what that release looks like. So I'm going to go edit that guy. We can see that my release has 3 stages. It starts with the artifact. In this case, it is the finishing of the build process. When the build process finishes, it triggers the artifact drop. I don't have anything in there since I'm storing my deployment artifact in that container. I'm just storing it in container registry. That then triggers my dev deployment to happen. And my dev deployment, when it's finished, we'll start that approval process. I set that up by clicking on the little lightning bolt here. And it says, and I've set up here that says, hey, Sean has to approve this, right? I've enabled pre-deployment approvals and Sean has to approve this. So now I have an audit trail of who approved what code to go into what environment. Inside of any one of those stages, I have a very simple task. Obviously, we have a great integration with Azure, so I have a very simple task here that says, hey, go deploy to my web app for containers, this dev instance, the container that you found in my container registry with the right build number. So it goes and grabs the container and drops it out onto into my environment. Now this is a very simple one. I can have steps in here that say deploy. You mentioned AWS. I can deploy to AWS from here, right? I can run PowerShell commands. I can run Bash scripts. I can do all kinds of things from here. Android, Ant, you name it. There's a lot of options here. And I have the ability to reach out into a marketplace of third-party options as well. So to pick all kinds of different things going on. This is how I integrated that white source tooling, right? By reaching out from the marketplace. And it's pretty simple to build one of these if there's something that's not there, or you can just put it in a PowerShell script or whatever, or a Bash script. So that is my deployment pipeline. You can see each one of these tasks is very similar. The only difference is I'm deploying to test in this case, and then the other one is I'm deploying to prod. So all I did was create the first one, then copy it 3 times, and set up, and then just change the deployment target. The nice thing is I now know that all of the code that's in each environment is the right code for that environment. And I can also see which code is in what environment. So if I go back to that chart, here you can see that in dev and test, I am currently deployed the release 2 instance, right? And that deployment was successful, and it's waiting on me for prod deployment. But currently prod is still running release 1. So I know just by glancing at this screen which versions of what code are available. I can even drill in and see the actual build that's in that code, and I can drill all the way down into, hey, what committed that code that's in that build? What changes are in that build, right? What work item was done, was completed to fix that step? So I have all of this. I have full traceability into the whole process. So I am going to go back to my pipeline and my build pipeline, and I'm going to, not my build pipeline, my release pipeline, I'm going to approve this guy for production and approve. That way that guy starts going out. You probably also noticed I have a second pipeline. I have 2 pipelines. One deploys my application, deploys my code. I have another one, an infrastructure pipeline, that deploys all of my infrastructure. So all of the things that I've built out here in Azure, I haven't gone through the portal and clicked on things to create all that stuff. I've created an ARM template, which is basically a big giant JSON document that describes what all of those things look like, so that if I need to change any of those things, right, I can release those changes, release changes to my infrastructure, whether in my case, it's just simple app services, but it could be virtual machines, it can be virtual networks, it can be all that stuff. I can have all of that infrastructure described in that ARM template, in that JSON document, and I can deploy and version that just like I do my source control. I get the visibility into what's deployed to which environment has what set of infrastructure. Now, mine is a little sample app, so I'm kind of leaning on shared components that I might not want to build that way in a real environment, but you get the idea. So that release should be on its way. My application is still releasing. And he's still going, so we can see him go. If we go look at the logs, we should see that container go get pulled and then drop out to our Azure App Service production instance. Come on. I don't like waiting for things. Oh, release 2. Okay, so it looks like it finished. So let's go back over to our actual running code. We refresh the site. It's probably still downloading those all the container dependencies. My contact page still works, and now my about page works as well. So I've fixed my bug. So let's go back and look at our Azure board with our work items, and we can see that the work item, when we started working on it, we moved it into the active column. When I closed the pull request, it moved itself to the resolved column, right? I closed the pull request. I resolved that bug, right? I didn't have to manually go in here and update that. Now that I'm finished with that with the issue, I can go ahead and just drag and drop it into the close column. I'm all done. The state's marked close. I now have fixed my problem, deployed it all the way through the pipeline, and it's running out there in production. So let me flip back to the PowerPoint for a moment and wrap some stuff up, and then the floor will be y'all's for some questions. So we saw that end-to-end pipeline, right? We saw all the things together, right? We've seen the integration that you get when you use them together. But as we mentioned, right, there's nothing that says you have to use them together, right? If you have things that you already love, if you can use those things. If you think Jenkins does a better job of deploying stuff, of building stuff, then go ahead and use Jenkins. If you're going to use Terraform instead of ARM templates, go ahead and use Terraform instead of ARM templates. So you have access to all of that stuff, and you can integrate all of that stuff inside of Azure, right? Inside of Azure DevOps, right? So there's plugins from all the major vendors and all the major open source projects to use that stuff from within Azure DevOps. And it's not only the story about Azure DevOps, right? We spent a little bit of time talking about application insights as a monitoring tool, but that's only one piece of the monitoring that's available in Azure itself. So if you're deploying to Azure, you get advantages of all that monitoring information. Frankly, you can use application insights from any application. Technically, you can use it from any application anywhere on the planet. So you can use it from an application running on AWS, on GCP, on your local machine, in your data center. Application Insights will collect telemetry anywhere. Now it sends all that telemetry up to the cloud. The cool thing about Application Insights is it has a free tier as well, so you can use it with. So I argue that for just about any project, it's a good idea to turn it on, because having the information is better than not having the information. You can also integrate with other pieces of the Azure ecosystem. I didn't demo it today because, frankly, I didn't have any secrets, but I can integrate with things like Azure Key Vault, where I can store in a hardware security modules, physical hardware, my secrets, whether that's passwords or secure keys or what have you. I can store those secrets in hardware and store them securely in Azure with all the right FIPS compliance and all the other jazz. We talked a little bit about infrastructure as code. I told you that I was deploying that ARM template. I showed you my infrastructure deployment using ARM templates, and I mentioned that you can use other things if you like other things better. We talked about application insights and Azure Monitor. To really drive home the point, right? It's not just our tools. You want to use Trello, go ahead, use that, right? I'm not going to be dogmatic and say use one or the other. I think our tools are awesome, but there's much more options out there, and I understand that, and Microsoft understands that. It's used by not just little tiny demo projects like I showed you. There's real customers using this stuff. One of them being, well, Microsoft. Not only our Azure DevOps team, but our internal teams use Azure DevOps at scale. So we're doing 78,000 deployments per day with 4.4 million builds a month, all working off of Azure DevOps running out there in the cloud. The other cool thing is when I look at this, if you go to this aka.ms DevOps at Microsoft, this talks a lot about the journey that our DevOps team did. So a lot of the people and process things that we learned along that way are documented in that DevOps at Microsoft article series. So really good fodder for you to use when you're talking to your customers about their DevOps journey. So TFS versus VS. So if I'm using the managed services, this is talking about the managed service, the URL changes, and there's some other small tweaks. Like we reduced the price, we made public projects free. We include 1,800 build minutes a month, up from 240. So how many hours is that? That's a lot of building. So using these tools, I understand that maybe you don't have the right project at work for it, but frankly, I use these tools to build my website and to build all the little projects that I do in outside of my day job, just because it makes it so easy to do all this work. Cool. Here's the migration stuff. There's a little short link on how to migrate from TFS to Azure DevOps, and it talks more in depth on that. And there is the conclusion slide to kind of give you an overview of what we've done, right? Namely, I think we've talked through a lot of it, right? We've been able to go through that whole DevOps lifecycle. The thing that I really love about Azure DevOps is I think it has really good solutions for all of the pieces, like work item tracking, source control, build, release, test, and artifacts. and package management. It has really good solutions for all of those, but all of those solutions can be used independently, can mix and match with other open source tools, or can be used for an end-to-end workflow that provides you really awesome traceability for all of these things. And like I said, I use it for free in the small teams mode for Sean, the home person that develops random stuff for the family. So the small teams thing, for up to 5 users, you can run all of this stuff in the cloud for free. For open source projects, so if you guys are working on open source projects, you can build and use boards and repos for free. And for teams, if you have in the enterprise, if you have a team that's larger than 5 people, you can either purchase it by the seat, or it comes included with things like your Visual Studio subscription. So if you have a Microsoft shop that already has a Visual Studio subscription, they already own all the licenses they need for using all of this stuff. So there's no additional charge. So it behooves you to take a look at that, because now you don't have to go talk to the finance people and say, there's an additional charge for you guys. They already own the licenses for this.